Okay, so what I want to do now is I just want to go over the problems that we have assigned for Module 5 and make sure we have, a good handle of where they are, what we're going to be doing, and what we're going to be calculating, and then also relate them back to some of the problems that we've done here in our practice problems. So, so we're going to start here on page 174. This is out of your McGraw-Hill ebook, okay? So I'm going to go underneath here. I do have it here. I know this is kind of shiny paper. I'm sorry. But the first problem that we have is problem 4.1. And you're going to do both parts, okay? So it says, for the beam loaded as shown, determine the reaction at A, which is right here, and the tension in cable BC. So this is a cable. The body is the beam itself, okay? All the external forces that you see here, you have a pin connection at A, and then you have a cable pulling away. Don't do anything with C. You're just going to show a line coming down with an arrow that's going to represent the cable pulling away from the body, being in tension along that line that the cable is making, which is vertical, and it's going to be pulling away from the body. So you'll have 1, 2, 3, 4, 5 forces, applied loads. Then you're going to have one reaction in tension pulling away at B. And then you're going to have an X and a Y at A. And those are going to be the reactions for the pin. So solving for those two reactions, the cable, the tension in the cable at B, and the X and the Y at A. The next one that you have is going to be problem 4.7. Okay. Problem 4.7. Now this one worded wise, and when we look at it, you might kind of wonder what that means. So let's talk this one through as well. So for the beam that you see loaded here, determine the range of the distance A. So this is a distance A. This is from the end capital A, and we're looking for distance lowercase a to where this 300-pound force is. For which the reaction of B does not exceed 100 pounds going down or 200 going up. So what you are going to do is you are going to solve this twice. The first time is going to be at B, you're just simply going to put a force going down of 100 pounds. That's what the first part says. And you are going to solve for your value of A. I suggest summing around point A. That seems to be the most direct, okay? You could sum around D or you could sum around C, but it seems to be the easiest to go from A. So I would suggest summing your moments around A, which is the end. And then wherever you need the distance A, you're going to just use it as a variable, okay? Then you're going to solve it a second time to get the other side of the range when you have B reacting going up at 200 pounds. So it's going to be first 100 going down and then second 200 going up, okay? You will have to also solve for the reaction at D. D is a pin, so there's going to be a dy and a dx, okay? So you'll be able to solve for that, some of the forces in the y, and it will change depending on your value out at B there, okay? So this one you're going to solve twice, and you're going to get a range then, a minimum value and a maximum value. The answers are in the application problem page in Canvas. All right. That's kind of a hint.
I got a question. Oh, sorry.
Yeah.
On point B, is that a pin as
It's
well,
not.
or
Nope. It's nothing. It's all it's going to do is it's going to bump up against either side. So you represent it with the force that you see here. So it is not a pin. It isn't a reaction. It's
okay,
kind of
okay,
like
I
it's just
was a
bumping up
little
against the surface.
okay, I thought it was a pin, so
Yeah. No, that's okay. The pin is at D.
yeah.
Yeah.
I thought B was a pin. So
Yeah, it is a little
thank
bit
you.
different. So I wanted to explain that to you. So that's kind of your hint. And again, the next time we meet, if you still have questions on this one, we definitely can go over it. Okay. So that's 4.7. The next one you have is going to be 4.10. It's going to be on this side. Okay. 4.10. It says that we have two links, AB right here, and DE that are connected out at the ends here at B and D of this bell crank, okay, as shown. It says, knowing that the tension in link AB is 150 pounds. So what that means is you're going to draw a vector along B to A. It's going to point away, and its magnitude is going to be 150 pounds. Okay. Then what you want to do is you want to determine what is the tension in the link DE. Since it says tension, it too is going to be pulling away from D, going down to E. Okay. And then what is the reaction at the pin at C? That's going to be an X and a Y. Okay. So that one is 410. The next one that you have to do is 13. Okay. 13 is at the bottom here of page 176. And it is going to be the illustration that you see here on the left-hand side. Okay. Here you have an L bracket, if you would. You've got a force of 75 pounds. You have a pin at A, so an X and a Y reaction here. And then you have a roller at B that is up against a surface. And what you're going to be doing is you're going to be doing it so that A is equal to 0. So that means it's going to be horizontal for A. Then it's going to be 90 degrees for part B, and then 30 degrees for part C. So you'll do it 3 times, changing the angle of that support surface. Okay. So that's 13. The next one you have is 23. 23. If you recall from our guided notes, we did practice problem 422. And this problem then is going to be what 23 goes off of. Do not use the description here. Instead, I have notes in the application problem page in Canvas. So if we go over here, use these notes right here. All right. So what you have is work the same for 422 with a weight of 75 pounds. Okay. And then you're going to solve for your reactions. Right. So 75 pounds is going to be the weight of that counterweight. So everything else remains the same, the 40, the distances, but this time your W is 75 pounds. So at B, you're going to have a force going up of 75 instead of 100. Okay. So that's number 23. And then there's 2 more. You're going to be skipping over to the next section. And on page 183 is problem number 429. Here we have a 12-foot wooden beam. It weighs 80 pounds. So they put at the geometric center 80 pounds going down. It is supported by a pin at A and a cable going along B to C. Find the reaction at A and the tension in that cable. Right? And then your last problem, turning the page, is going to be number 37. Number 37 is simply redoing problem number 36, which was a practice problem for us. It was the last problem that we did. And you're going to be changing angle beta to 60 degrees. So angle beta is the angle that the 150 newtons makes with vertical. So you're going to do that very same problem that we did in the practice problems, but now this angle changes to 60 degrees. Okay. And those are your application problems that you get to do for Module 5. Any questions at the moment on just kind of the basics or any clarifications on the problems themselves? All right. If not, then I'm going to stop this recording here.